Swinburne podcasts.
Often we think of a simulation that we want to perform and realise that it's going to take 6 months or a year for the calculation to complete, and we'll sit around and joke that what we should do is go on holiday for 6 months and wait for Moore's law to give us faster computers, and then we'll be able to do it in 1 month. So, I mean, it really does help. Things that we could not contemplate 10 years ago are easily within our grasp now.
Here we have a supercomputer, the fastest in Australia, so we often do some of the very computing intensive work here, and then we might send the data back across the internet to our colleagues to do some other aspect on the data.
Well, I think astronomy has advanced a lot in the last 20 years, and I can see it continuing along the same lines. The internet, although it's extremely important now, will actually become the main way that astronomers get their data. So rather than astronomers going to the observatories themselves, which some of them still do, it'll be basically you send a file and the support astronomers at the observatory will take your data for you, and you'll get delivered that via the internet. And that happens about 60% of the time now, but in the future I think it will be the majority of the time.
We can take about 10 gigabytes of data a night, which is a number that's familiar with a lot of people with sort of home computers nowadays. So if you're here for a week, you'd probably take data equal to about the amount of data you could store on an average home computer.
Astronomy is moving into a regime where we're getting flooded with data, and it's coming at us so fast that having a supercomputer in order to deal with all that data is invaluable.
We deal with such large data volumes, something that perhaps didn't happen in the past. So the combination of the internet and computing is absolutely crucial to making progress in astronomy.
I was just starting my research career as internet kind of really took off, and so I've in some sense always been an internet astronomer, probably one of the first generation of internet astronomers. It completely changes everything you do. So you can now do studies on very, very large data sets that, people have always been observing large swathes of the sky. But now with the ability to distribute that information to people who might want to look at different aspects of it, it means that so much more can be gleaned from those data sets. And so, for example, I use something called the Sloan Digital Sky Survey, which was a big optical survey both in photometry, taking pictures of the sky, and spectroscopy, taking spectra of individual objects in the sky. And that means that there's an enormous amount of data there, and consequently you should be able to get an enormous amount of information from those data, and that's what I've been doing. But this just wouldn't be possible without actually being able to just download the data, look at different ways of viewing it on the web, searching through archives, searching through other databases to match what you see in this particular survey with other surveys. That just means that you're getting a much more complete picture of the data that's currently available for any given object of your choice or any given part of the sky.